Hello and welcome to the future of the U.S. military in space. I'm Greg Piquel. This is Defense Space Tech, and today I'm going to explore where the United States, the DOD, and the U.S. Space Force are heading in the very near future. First, a disclaimer. I've been working in and around the Department of Defense for decades, but I have no direct connection with the DoD space community or the U.S. Space Force, and that's a good thing. DoD classifies the heck out of nearly everything these days, and if I worked closely with the Space Force folks, I wouldn't be able to talk about any of it. I'm a retired military officer and a passionate observer of all things space and defense related, which makes me reasonably qualified to talk about the issue at hand. Okay, one more thing to get out of the way before we dive into what I like to call the Navy in space. First, if you ask the leadership of the U.S. Space Force, the USSF, about manned maneuver assets in space, they will reflexively say they're already doing it. They're not. Satellites with a bit more maneuvering fuel and the X-37 spaceplane are great, but they are not the same thing as manned maneuvering spacecraft. Today, we're going to talk about SpaceX, the Starship spacecraft, and the near-term ability of the DoD and USSF to deploy manned multifunctional spacecraft in low Earth orbit and to keep them there for as long as needed. So strap yourselves in for a ride like you've never seen before. To understand why we're talking about kind of issues we're looking at today, a little bit of context in an order. SpaceX has been around since about 2002, and they've been flying rockets more or less successfully since about 2008. More importantly, since about 2015, they have been launching and landing orbital class rockets, something that no one else has ever done. In 2019, they started on a whole new chapter, and that's in a place called Boca Chica, Texas. Boca Chica, Texas. This is a little mudflat just north of the Rio Grande in southern Texas. More to the point, it's on the Gulf Coast, which makes it ideal for launching rockets. In 2019, SpaceX began experimenting with a system called Starhopper. This is basically a grain silo with a rocket attached. But what they were developing was the ability to launch that vehicle, control it in flight, and then land it safely. This phase was successful, and that was the first step. Once the SpaceX engineers had mastered the launch and landing of Starhopper, they moved on to a much more ambitious phase of the effort. This involved testing a full-sized vehicle called Starship. This was a big step because Starship was essentially a full-blown second stage of an orbital-class rocket. This time, they flew the test article to roughly 60,000 feet, flipped it around, flew it back to the launch pad, and landed it. This was revolutionary on a number of levels, and after a few rather spectacular attempts, they were successful. All of this leads to April 2023. That's when SpaceX flew what is called the full stack for the first time. That's the super heavy first stage booster with the second stage Starship stacked on top. As of June of this year, 2024, SpaceX has flown that configuration 4 times, each time with greater success. I should note with SpaceX, even the partial successes are pretty spectacular. The last 2 flights have made it to orbit, and the latest test saw SpaceX bring both stages back to Earth for controlled landings, an unprecedented achievement. That needs repeating. We're talking about the world's most powerful rocket flown to space and returned to Earth for reuse. Okay, so where does this get us? I mean, this is all well and good. You've somehow managed to create the world's largest rocket. You've flown it to space. You're iterating rapidly. Everything's going reasonably well. But the real question that you have to ask yourself if you're the Department of Defense is exactly what does this get us? Well, quite a lot as it turns out. So what does this all mean? What is it that the U.S. is going to get out of this? More to the point, what is the Department of Defense going to get out of this? And the answer out of the box is a rocket so massive that it can deliver over 100 tons of payload to orbit. And to give you an idea of just how crazy that is, the current Falcon Heavy, which is the strongest rocket currently in operation, can lift 64 tons to low Earth orbit. The Delta IV Heavy, which has been around for a lot of years, can do a whopping 28 tons. The SLS, which is still being built out today, when it's done, will have a capacity of around 95 tons. So 100 tons, growing, by the way, to 150 tons, that's a really, really big deal because while that's currently portrayed in terms of satellites, things like that, just imagine if you wanted to put a military payload or a crew on a ship like that. Not hard to do. The second thing you get in SpaceX's Starship is a fully capable platform, one that is able to remain on orbit for extended periods. Other than the space shuttle, no spacecraft has ever come close to what SpaceX is building in terms of capability. Even the space shuttle had severe limitations on how long it and its crew could remain in orbit. In fact, the longest space shuttle mission lasted just 17 days, with planned missions lasting between 5 and 16 days. With Starship, we're talking about the ability to stay in orbit for weeks or even months at a time. Starship is completely different in a variety of other critical ways. SpaceX intends to fly this ship to Mars, so endurance is kind of part of the package. In addition, life support, crew quarters, cargo capacity, engineering spaces, instrumentation and navigation packages, and so on, they're all part of the basic design. Keep in mind as well that second stages on most rockets are severely limited in their utility, being effectively restricted to deploying whatever payload is on board and then being discarded. No second stage of the type SpaceX is building in Starship has ever been deployed, and the implications for extended manned spaceflight are huge. What do you think? Will we see a Navy in space in the near future? Please like and subscribe as we journey together into sci-fi that's all too real. This next attribute may just be the biggest one of all, especially from DOD's perspective. In Starship, the Department of Defense gets a spacecraft that is quickly deployable. It gets a ship that can take off, land, refuel, and take off again in as little as a few hours. This is unprecedented on a number of levels. As an example, the space shuttle was reusable, but it required extensive refurbishment between flights. Shoot, it ended up costing more to refly than it did to use disposable rockets. Equally as bad, the shuttle required turnaround time between mission that was measured in months. Because it views rapid reusability as critical to its Mars colonial goals, SpaceX is pioneering landings that aren't followed by refitting and inspection and replacement of damaged components. Among other things, they plan to catch returning boosters and starships in midair to avoid damage to the landing legs. We'll hopefully see that demonstrated within the next few months. All of this means that for the very first time, the Department of Defense would have access to an orbital spacecraft that can spend more time in orbit than on the ground. That's a really big deal. The next thing you get with Starship is a rocket that is both reconfigurable and able to be produced in a very short period of time. Traditional rocket development and production is incredibly inefficient, and for good reason. It's going into the most unforgiving environment imaginable. Unfortunately, that also means that development and operational deployment of space platforms and vehicles and spaceships is crazy expensive and time-consuming to boot. NASA's Space Launch System, for example, has been in development for over a decade, and that's not unusual. SpaceX, on the other hand, is developing a modular design that can be reconfigured for a variety of missions, and they are shooting for a complete rocket out the factory doors every 3 days. You heard that right. As crazy as it sounds, the effect on costs would be even more profound. A great deal of rocket development lies in labor costs, not materials. And SpaceX's 72-hour target reduces manpower costs by as much as 90 to 95% over any existing approach. We may be looking at a revolutionary capability that also just happens to be the cheapest orbital platform ever built. So what does all this mean? It means that we, as in DOD, Department of Defense, are looking at a low-cost, reusable space vehicle that can go to orbit or anywhere else, stay there for long periods, execute multiple mission profiles, return to Earth when necessary, and then redeploy in hours or days, and all at a surprisingly low cost to build and operate. It means that for the very first time, the US will possess a military space capability unmatched by any competing power. It means, in short, US dominance in space for years, if not decades, to come. The Starship effort has really profound implications for what DOD wants to do in space. No one has ever considered seriously putting maneuver assets, to use a DOD term, into low Earth orbit. That's about to change. In the next installment of this journey, we'll consider how all this might actually become a reality. We'll take a serious look at how these forces might be organized, how they would be equipped, who would control them, and how they would be supported. We'll even take a stab at what terminology we might need to create to describe this new capability. Stay tuned. There's a lot to discuss in what I would prefer to call the U.S. Space Navy.